All right, so I had a reader ask me about, or they mentioned how they didn't really understand the non-commutative music math, and so that inspired me to dig a little deeper. And one of the quotes that I've used is from an article stating that the Heisenberg uncertainty it or the time frequency uncertainty in quantum mechanics is from non-commutativity or non-commutative time frequency. And to me, that it makes sense intuitively, but the precise mathematical logic had sort of eluded me. I hadn't looked into it. So, yesterday I happened upon a pedagogical paper arguing that if you explain quantum mechanics having a de facto uncertainty principle of position and momentum, then you can logically explain why the imaginary number has to be used in quantum mechanics. And essentially, the mathematics works out where when you use a imaginary number to square the magnitude as amplitude for the probability, then you get a constant that would be a value of 0 for the position when you're measuring the momentum. So if you have a precise momentum, then the imaginary cancels out for the probability. So then the constant value would be a 0 in terms of a wave, because you're talking about the de Broglie wave of matter, the wave model of matter. And so the what's called the particle wave duality is fit into the probability from the imaginary number. And this is it's just such a great way of explaining quantum mechanics, because you're explaining several different things at the same time. And of course, with the de Broglie quantum wave model, the frequency is directly proportional to the momentum. And then the location is the wave length, the phase of the wavelength. So this also explains then why the probability is based on the unit sphere of the block sphere using the imaginary number, but can also be the non-commutative torus, because the imaginary number requires the non-commutative inner product in the matrices, the matrix math. And so what is very radical about the Alencon argument and how it's connected to music theory is that in standard quantum mechanics, due to the time frequency uncertainty, or the position momentum uncertainty, the particle and the momentum are considered random and indeterminate until the measurement is taken as the probability, what's called the wave collapse. And so the problem is that each time you take a measurement, it's inherently unpredictable because it's non-commutative with the momentum. Therefore, there's no way you can have a trajectory from the previous value. And so how this relates back to music theory is that the what Alencon realizes is that the type 2 factorization of von Neumann is using the non-commutative inner product of the matrices. So this is the equivalent of the time and frequency in the music theory. So with the type 2, it's the equivalent of having a like a wavelength of 0 to 1 because of the block unit sphere of the imaginary number, from the probability of squaring it. But because it's non-commutative, therefore it has to be an inherently unobservable and unknowable infinity that is actually 0 to infinity. And yet, since it's non-commutative, it is also time and frequency. So therefore it is 2, 3, infinity is what Alencon calls it. So again, this is what I had realized intuitively when I was a teenager, that the secret of the Pythagorean infinite spiral of fifths was a harmonizing force of reality, of time and frequency. And the whole way it works is that it's not materialistic, so it's before there's any spatial wavelength. And so once again, because it is inherently unobservable, therefore it has a geometric dimension of 0. And this is because the inner products are the inverse exponential, so that you do a quotient of the logarithm, which means you subtract the inverse exponential. So then you get the quotient as the non-commutative ratio. So it would be 3 to the 1/19th minus 2 to the 1/12th is therefore the perfect fifth, or 3/2 to the 1/7th, and then this is greater than 1 as a infinite convergence because it is non-commutative as the inner product of the inverse wavelength. And then you subtract that from 1, or so the value, since it's the convergence is greater than 1 because it's 3/2 to the 1/7th. So that means when you take the inverse of the exponential, then the value that is always less than any positive number. So the constant value is a geometric dimension of 0 based on the spatial location. And so that's how you are determining the coordinates of a object that has a 0 point in space if you only know the frequency of the light from the spectrogram or spectrography. I don't know the word for that, but spectrometry or something like that. So some of the math I don't have down precisely, but the concept, I have a better grasp of the mathematical logic involved in the concept. And the key point here is, how is it related back to music theory? Because the whole point is that, yes, it is unobservable, but that does not mean we can't listen to it. And since we are proven to listen faster than the linear conversion of time and frequency, or the time frequency uncertainty, that means that the listening is also inherently non-commutative. And since the empirical truth of the listening is also the non-commutative Pythagorean ratios of 3/2 and 2/3 as the perfect fifth, since we listen to the root tonic of the one as the fundamental, as the true fundamental force, therefore we don't have to observe the light, and the truth is rather a 0 point in space as an absolute void that radiates light eternally as a infinite harmonization of complementary opposites, or yin-yang, or the three gunas of India, the Pythagorean perfect fifth, that's non-commutative as 2/3 and 3/2. And so the doubling to get back to the 0 to 1 wavelength is the type 1 von Neumann factorization. So in music theory, you're taking the undertone of 2/3 and then you're doubling it back to 4/3. But in reality, the major second music tone as 9/8 is derived from the squaring as 9/4 from 3/2. So it's 3/2 squared to 9/4, and then you are having it back to the 9/8. And so in the doubling and the halving are already assuming a double octave, which actually is using a different root tonic for the to derive the perfect fourth, so that the wavelength is actually the symmetric irrational number magnitude by changing the fundamental frequency as the root tonic. And this is what Philolaus did by flipping his lyre around to make it non-commutative. So therefore the root tonic is changed from 12 to 8, and then you take 6/8 as the wavelength to get 4/3 frequency, but you're listening to the 8 as a changing of the root tonic, because it's a geometric dimension of 0. So therefore the wavelength is constantly changing as the secret non-commutative geometric dimension of 0 against the time. So the symmetric magnitude to square the octave for the music theory as the spectrum scale of the 2 is actually for the 0 to 1 wavelength as the type 1 factorization of von Neumann. It's not a doubling and halving, but it's actually from the squaring. The assumption is the octave. The 1 is already the squaring from the imaginary number due to the inherent non-commutative time and frequency. So the 1 is already a squaring due to the imaginary number as a fifth dimension of a geometric dimension of 0. So the fifth dimension is just time itself. So the 0 point in space is actually inherently already non-local time of the future with a reverse time and negative frequency overlapping. So that would be the 2/3 frequency with the reverse time, and then the 3/2 overlapping as a positive frequency. And so the wavelength is 0 to 1, but it has to be, since it's non-commutative, it has to be a infinite 0 and infinity, because the frequency and the wavelength are longer than the geometric magnitude of 0 to 1 as a symmetric rest frame of relativistic space-time.